Okay, number 39, in fact, all of these, I believe, are tree problems. And the only way that I could tell you to recognize a tree problem is that, do you see here that we have day and night? And either you're absent or not absent. And I can view that as a table, right? You know, what shift you work and whether or not you're absent. I can see that as a table. So that should be a good deal that this is going to be a tree problem. All right, so either the person works the day shift or they work the night shift. And I think it says that 60% work the day shift, and then so that means 40% work the night shift, because remember, one branch has to equal up to 1. All right, so either you're absent or you're present. But I'm going to write not absent. You can write present, not absent, and then absent, and then not absent. Now remember, for a tree, whatever is your second branch has to be the same. They have to be able to repeat it. And it says here that 1% of the absences, okay, will miss work. So this is 1%, 0.01. So this would be 0.99, right? Because each branch has to add up to 1. And this would be 0.02 and then 0.98. Again, each branch has to add up to 1. Okay, so notice what I did is that I found the probability. Now let me get another color. Come on, another color. Look at day and absent. So that means if you multiply 60 times 0.01, you get 0.006. And if I want to find the probability that somebody works the day shift and they're not absent, that's 0.60 times 0.99, which gives me 0.594. Okay, now I emphasize the and so that you know to multiply. All right, so let's go to the first one. And they want to say, is absenteeism independent of shift work? Explain. And this says, what percent of employees are absent on any given day? Well, let me do B first. I don't like that first one, independent. I'm going to have to do some math. Okay, let's see if they're absent, the probability that they're absent. So I'm going to check this is absent and this is absent. So let me do B. Okay, so that means that I could be this way or I could be this, correct? And whenever we say or, what do you do? It's going to be, you add. So it's going to be 0.006 plus 0.008, which gives me 0.014 or 1.4%. All right. Okay. All right. And so let me talk about independence. Okay, I'm sorry, that independence problem took me by surprise. I thought this was strictly a tree problem. So let's go talk about 39A. And let's get out a different color. All right, so if we go look at our formulas for independence, we have 2 of them. The one that I'm going to use, because I think it best fits a tree, is the conditional one. So the probability of A given B is equal to the probability of A, then we are independent. All right, so I'm going to say the probability that somebody works the day shift, given that they are absent, does that equal to the probability of working the day shift? Okay, so the probability that they are working the day shift, given that they are absent, is the probability of D/A is equal to the probability of D and A divided by the probability of A. Now we found the probability that they are absent. That's this guy right here, 0.014. The probability that they are working the day shift and they are absent, that's this guy right here. All right, so let's go do the math on that. So 0.006 divided 0.014, and I get 0.428, okay? Now, does that equal to the probability that they worked the day shift? Well, the probability they worked the day shift is 0.6. So do you see that they're not the same? They are not the same. So therefore, these guys are not independent. Okay, I'm going to go to another, let's go to purple. And let's go do problem number 41 because they use the same chart, okay? So problem number 41 says, what percent of the absent employees are on the night shift? All right, so I hope that you see that this is a conditional probability. So what they are asking here, what is the probability that somebody works the night shift given that they are absent? Okay, well, let's go look at this. The probability that somebody works the night given that they are absent is equal to the probability of night and absent. Oh, would this go away? All right, this is making me mad. Okay, I'm not playing that game anymore. I'm going to erase this guy down here. I'm sorry, I feel like it. This is all going crazy. Okay, I have to erase this because that bar won't go away. All right, so let's go back. So I have to find the probability of they work the night shift, given that they're absent, is equal to the probability and absent divided by they are absent. Now we found the probability that they are absent is 0.014, and the probability of the night and absent, that is 0.008. You put that in your calculator and you get 0.5714. So my answer is going to be 57.14%. All right?